Hi YouTube, welcome to the second part of this Impl series implementing Meatpack. So in the last episode, or the first episode, we had got to the stage of just implementing the algorithm where we were packing a series of bytes from their U8 representations into a U4 representation for the 15 most commonly used characters in G-code. And we had a forward lookup function here. We also did a reverse lookup function to then, of course, return those U8 U4 bit representations back into a U8. We also have this flag that we'll be using now to say declare whether a byte is a special full width character that isn't represented by the 15 that we have U4 representations for. We created an unpack function which took a U8 and unpacked it into the two. So it took the two 4-bit representations within that U8 and unpacked that for us. And then we attach those functionality into traits. So we have a pack trait and a pack tuple. So the pack trait was implemented on a U8. So anywhere we have a U8 in our library, we'll be able to then use the pack and unpack functions to quickly create the U4 representation for it, or unpack it into if it was a couple of U4s within a U8, we can unpack that into two U8 G-code values. We also had the pack tuple, that given two U8s as a tuple, we can actually pack those in and create the U4 single packed representation of that. So that gives us the base functionality then to create our meatpacking library. So we're going to create a packer and an unpacker. We'll see how we go to in this episode to create a packer struct, and if we've got time we might go straight into the unpacker. If not, we will continue into another episode. So the packer will create a new file called packer.rs module. So we just need to pub, and actually we'll create these ones are going to be pub create. So we're not going to release all this functionality to the world. We'll just publish it internally into the create, and you'll see actually in and I can show you that in our, so this is the actual Meatpack library. What I've got is the actual components. This is what we're building out in this series. I keep these all, like, if I go to this mod here, which is the one that I just was editing, everything is pub create, so I can use it within the libraries because it's all in library internal functions. But also then, when I want to expose certain elements like the API to other people in the library, top level library, I then go into those components and identify the ones that I want to expose to another user. That's where they get exposed. But I don't think we'll get to that stage in just this implementation video, but that's how, if you want to start exposing APIs or elements, and you can expose them from the components section as well. There's no reason why you need to expose them at the library, but given it's just a small library in itself, I didn't want to expose all the little bit of details here. So anyway, so we've created a crate called packer, and we've got to remember that we're in a no stud environment, so we do not have the ability to create vectors unless we use an external crate that afforded a lock to us. So what we want to do is create I created a struct called packer, which is going to provide our packing functionality. And what it's going to have is a user-defined usize. So we can give it, say, a const s usize, and this is something that the user of the function of the packet, the struct, can define. So if they're using it in an embedded environment, you can then say set the maximum pack buffer, so that what we're going to use that usize is to define how big the buffer is going to be for the packer, and the packer is going to maintain and manage that buffer internally. So it could be like 64 bytes, 128, 256, whatever it may need to be for the packer to for the functionality and the availability of memory on an embedded device. You may not necessarily need it for the packer as such, because you might not pack on an embedded device on a 3D printer. Definitely on the unpacker, you can imagine that be put on an embedded device. Just for the simplicity of the API, I thought, yeah, why not represent it both ways and have the same representation. So the packer function, we have what we're going to have is a series of variables. So the first one I've got down here is as least. So the U8 in the pack, we've got the U8 has two 4-bit U4s, representing two of the characters. So the pack is going to be receiving. What we're going to do is it's going to receive bytes from some stream, some user, and each time it receives a byte, it's either going to say, "Can I pack this byte into the buffer?" Or do I not have enough information? So basically, if let's say we found that the byte was packable and we created a U4 representation, do I have another U4 representation to pack with it? If not, then we will hold it in the least, because this is going to go into the least significant bit as our first one. And then when we get another one, we'll put that in the most significant bit and then add it to the buffer. So it's kind of incrementally packing along as we receive bytes. We'll also have, I've got a variable called function for width. And this, again, is a similar thing, is, do we have a full width character so we can store it? And this is the fringe cases, and we'll get to them when I start implementing it, where you may have a U4 declaring, there's a full width byte following me, but also there's still that space for another 4-bit representation. So, if the next byte has a 4-bit representation, can we include it into that one so we get an extra little bit of packing? Otherwise, if it's not one, then we'll pack two flags to, there's a double full width characters coming along, so you can then unpack two full width characters. We've got another variable clear. So this is when to clear the buffer. So the idea is that we got these incoming U8s. We're going to slowly pack those into the buffer. When we reach a new line, we're going to go, we've completed a line of G-code, and we're going to release that back. So we're going to give the user the slice into that buffer is the full pack, the packed version of that line. And if we look into the algorithm, it doesn't actually pack along the line. So when we do reach a new line, it's like that then either has a double new line or a single new line at the end representation. So you don't have to, we can release lines of packed code each time. So the clear is, we've released it, I'll put this clear flag on, and the next time we receive a byte, we will clear the buffer and continue on. We then have the strip white space. So again, in G-code, white space bears no meaning. You can have white space between numbers, even though the number, let's say if we had 1.234, that could equally be represented as 1 space 34, or 1 space dot space 3 space 4. All of those could be equivalent to G-code. It just doesn't, when the interpreter reads G-code, it just ignores this white space. So why are we sending that white space for our serial connections? So like I said, we can then add that rule to strip any white space when it was the G-code was created. And of course, G-code is created not only for human machines to read, but for humans, and the white space is more for us, make it a bit more readable. So we've got strip then, strip comments. Comments in G-code are represented by a semicolon and then some comment. So you could either have a line start with a semicolon and that entire line as a comment, or it could be appended at the end of some G-code. So this could be like, G1x10, and then we could have some comment off the end. Again, those are for us humans to read. Potentially sometimes a 3D printer might print those out for us on a screen if you want some debugging. But nonetheless, they can be superfluous when you're printing, so we can have a flag there to ignore those as well if we want to increase the degree of packing. And actually, most of the full width characters will be within the comments, not within the G-code itself. So it will definitely help with packing G-code further. I also have a comment flag. And actually, maybe I could call clear as a clear flag. So these are just, it's always nice just to. So the clear comment flag there again is to say, right, we're in comment mode. I've detected a comment, we flagged it because maybe strip comments on. And then when we reach a new line, we will then want to say, turn the flag off, so we can then start packing the rest of the code for the next line. So it's just a way to say to raise a flag to start ignoring any bytes until we reach a new line, and then we'll uncomment again and then start packing bytes again. And then we've got position, which takes a usize, and inner, which is going to be our buffer. So the position is pos is going to represent the position in our buffer as we move along it and pack more bytes into it. And inner is our buffer of U8s, and it's going to be of size S. That's going to be defined by the users of this library. So now we can get into implementing. So we want to implement our functions for packer. Of course, we're going to have a const S usize. Default for packer S. Right. So actually, the first thing we're doing there. So I was just copying that from the reference. So default here is our default when you want to do packer. Don't call them default. What's the default settings? And it's just going to return self. So we're going to this is our version of implementing default. Because we want to probably have default as always stripping comments or stripping white space to maximize the maximize the packing. But we may want to have the other, like the clear flags, all set to false and comment flags because we haven't initialized. We haven't passed any bytes then. Because we've got default either or default to one of those values, we will need to make sure that we set them to the correct ones for our version of default. So fn default returns self, and it's going to go to the least. It's going to be none because we don't have any bytes. Full width is also going to be none. Oops. Clear flag is going to be false. We don't need to clear the buffer yet. Strip comments, we're going to say true because we want to maximize our packing. Strip white space will default to true then as well. Again, maximize the packing. The comment flag, of course, that's set to false because we haven't reached any comments yet. Our position in the buffer is 0, and our inner is going to instantiate the buffer of 0 U8 of size S. We're going to get lots of warnings there just to say we haven't read them or used them yet because, well, still building out the library. So now we're actually going to implement packer, and the functionality that we are going to use. So use size, implement packer. Oops. For S, who's going to have S, and we are going to do fn new. I'll put fn new, and this is just going to allow a user to have more control over the how to define self, and of course the packer self. So say it's going to have strip comments, it's going to bool, it's going to be strip white space, so give them control to change those. We're going to return self. Self. I just copy this across. And of course, rather than us define these, the user has. So that's the standard kind of new function for any struct that allows the user to define their own default values. Now we get to the real kind of the role of this packer function, which is the function that's the user's going to call to give us a byte to pack into this buffer. So we're going to call it pack. So we're going to accept, we're going to have a mutable reference to self because we're going to update our buffer potentially, or update the lease, or we're going to do some updates of our internal self. We're going to receive some kind of reference to a U8. So and we're going to return a result, and it's going to either be a meat. So we're going to define something called a meatpack result, because there's going to be a couple of different actions that I might want to take at the end of this. Meatpack error, which we've defined in the previous one, and we're going to probably add a few more errors codes as we go along. And I'm going to just add to do here so it doesn't just fry at me. The only thing it's going to say is that we haven't defined the meatpack result type. So I believe I stashed this in the meat.rs, and I shall do the same here. So we're going to have an enum called meatpack. Meatpack result. It's going to have a lifetime of A, and it's going to either return waiting for next byte. So it's going to say that that's for our stages where we haven't reached a new line, we're still packing, we've got information that we need to feed the line. So it's going to tell the user, yep, pass us another byte to pack. So from wherever it's coming from either a stream, some type of SD card, some kind of IO, yep, we need the next byte so we can then pack it into the buffer. If we have reached a new end of line, then we're going to say, hey, we've got a result, we've got a line for you, a line of packed gcode. And this is going to reference the internal buffer. So this is going to be a reference of lifetime U8 to our internal buffer. And it's going to be the slice of that buffer. It's not going to be the entire length of it. It's going to be whatever length of the packed byte that represented that. So it's going to have to exist. It can only exist for as long as the packer exists. So that's that. So in here now we can import that then. So that's our two results from packing. Okay, right. Let's go back to the functionality of packing in. So the first bit we want to do every time that we call, maybe we want to double check that self.clear flag. If it's true, then we want to do a run clear, let's call it clear buffer. I've decided to change these names from the ones that I've got in the library, but it's clear it's called clear in the library. It's hopefully not going to be too confusing, but as I type, I find it a bit easier to write it a bit more verbosely, and maybe I should do in the library itself. So this is going to be an internal function called clear buffer, or clear inner, because we call it inner. Why not clear inner? Got a mutable self, clear inner, and what we're going to do here is going to say self.inner fill with zeros. So it's just going to be go across that buffer, clear it out, just return it all back to zeros. We're going to return our position where we're filling up this buffer to 0. We're going to set self.clear flag to false. We're not going to clear again unless we flag it in our packing algorithm. Right, so the next couple of checks are if strip right space, self.strip right space is on, and the byte is either a space character. I like doing this as like, you can do this as an array, so of bytes that we're interested in, so space buffer or tab is often used. So this is the array. If it contains the byte, if our byte is one of those items, then we are going to just return okay meatpack waiting for the next byte. So we're going to ignore it because we're not going to include white space anymore, and you only need tabs in our output. Then the next one is if strip comments. So if self-strip comments, if this flag is true, then of course we want to, next thing before we go is if the byte, so if we dereference that, if the byte is a semicolon, there we go. So if it's a comment byte, then we can go self.comment flag equals true. So then if the byte equals byte dot slash n, is it a new line? And we can then see the comment flag is off. So it's just the two options. It's like, if we've got strip comments on, we're going to be running through a stream of bytes. If we hit the semicolon, we know we're in a comment mode effectively. Continue to ignore those bytes until we hit a new line, and we know we're coming out of comment. We're going to go and process a new line. Of course, if those haven't, so then once those have activated, if the comment flag is true, then we can return okay meatpack waiting for the next byte. So if the flag is on, then yeah, ignore whatever that byte is. We're not interested in it. Right. So these are just like, from some early just checks, given how interested whether we're using white space or strip comments. Now we get into the kind of the real check of how we're going to pack and what state we are in to pack items. So what we want to do is going to be creating a match on self.least. So whatever our option is, do we have a least byte in our store to be packed with another byte, or do we not? And then, okay, we're going to match on whatever our current byte is that we've just received. The first one, maybe the first option. Well, let's go. So of course we've got these options. We either have no least byte to pack, and we have the special option where we've reached a new line. And I'll add the implementation in a moment. So these are the options. So we have a none, we have none, and we just have some other byte. So in the new line one, of course, here we'll probably want to go, well, we're at the end of the line, we're going to have to return something. We're going to be returning a line there. If it's not, and it's a byte and it's not a new line, then we will want to pack that into the least. We also have, if it is some one, if it's the 16th byte, so byte number 15, yep, 15, do that. Just double check for my sanity. If, yeah, 15. Then we know we're at the flag. So we flagged it as a a byte. There's a full width character coming along. Actually, it's probably, I'll keep it with the representation I've got in the file. So, and we've got a byte. Then, oops, the byte is /n. So, do we have a situation where we're saying there's a full width character, but we've also got a new line byte? You also have a situation where we've got a full width byte and it's just a byte that we want to deal with. So this is the full width byte that we want to just add. Then so these are some special like edge cases. I'll go through them in more detail as we implement them out. And then we've got the case where, of course, it's some other least byte. And we have a new line, so we want to pack the new line with that and then return OK. And then we have the case where we've got a least byte with some other byte that we want to try and pack with it, or maybe it's a full width byte we need to handle. So that's what we got. We either got a least, we've got nothing in the least, but we've got a new line, so we want to return something, return a new line. We have nothing and we've got a byte, so this will probably go into the least, again, return waiting for next byte. We have a full width byte and a new line character, so we need to deal with that kind of edge case where we should be expecting a full width byte, but we've also got a new line byte, so we'll show you how that works. We have a full width byte and a unused byte, just a byte there, sorry, unused B byte. So that's going to be a full width byte. We might just append that and then go for waiting for next byte. We have the least, we have something in the least. So we have a U4 representation and we've got a new line. So we want to append that and return a line. And we've got a least. We have a other byte, which could be a full width or a U4, so we need to pack it to find out what it is and then return waiting for next byte. So that's kind of the general gist of all the options there. So I think it's a case of now let's implement each of those, and hopefully once you start seeing the implementation of how we stitch those together, you can see what the cases are. So if we've got nothing in the least, so we've reached the end, so we've been packing along and we've emptied the least, so there's nothing now, we're ready to pack a new item to go into the buffer, and we've just reached the end. What the algorithm actually does is just append two ends. So let's say we can say what the most significant bit is also a /b /n pack, and we then pass it, are we include the self.white space, strip white space, we're including those spaces to get the right lookup table. We expect this not to error because we have provided it with a packable character. Expect given this a packable byte, so something like that. So we expected it because we've done that. We could do, let's call it both. So both of them are going to be this packable byte. So then let pack, let's call it packed byte equal both dot pack. So we can use two ends, and of course we should say expect, like you say, given to packable bytes. So we know, because we know from our lookup table, if we've defined it correctly, that we should be able to pack that So we should be able to just unwrap it as a packed byte because the lookup table has new line included. We then, of course, we can then push that to our inner. So this is new function push. So we need to define it in a minute. So we'll do that. So rather than just go straight to push into the inner, we'll do create a function called push, mutable self, and it will want a U8. I think it needs which takes a U8, so it'll consume it, returns nothing. Actually, it will return a result, and the result will be empty, but it will be a meatpack error. I'll do for now. The error here will be whether we check whether there we go. Whether there is space in the array. So we need to create a new error saying buffer full. I believe I've got it as. So we can try and maintain some consistency with the library as it stands when I've done this video. It is, yeah, and so buffer full, yeah. So in here, call this buffer full, and I'll give it a error message of the buffer is full. And that may be where we've got to a, we're working on a very small embedded device. We may be even limited on the number of characters per line. So, yeah, like I say, you want to maybe pack to a certain line size. Nonetheless, it's an error that could happen. So, we first will go if self dot position is, there we go, self dot position is going to be equal to it's greater than s, so greater than the size. We are going to return the error meatpack error that is full. Yeah, that's good. Okay, so then otherwise we'll go to self.inner, wherever we are in the buffer position, we're going to give it the byte, and we're going to increment position. Oh, self.post. There we go. And we're going to return OK. Stuff. Okay, yep. So we've just, everything's unused yet because we're still building it all out. So we're going to do that, and we're going to put a question mark there. So if we return an error, we're going to propagate that up because we've put pack as result, pack result or meatpack error. So because that also adopts meatpack error, we'll just propagate it up. It's one of the errors that could occur. It could be really, like, say, if you're building a large library, you'd have separate error enums for all the different elements, because of course you're not likely to get, here you want maybe a specific error at one of the options. You may not get all the errors that are going to be listed in the enum, so you don't want your users having to deal with all the potential options, even though those options may not actually occur. So you would separate those out. Because the library is quite small and we haven't got too many different error types, I haven't done that. That's just a decision I made along the way, but we could make that better over time. So where did we get to? Right, so we have packed that byte. We've reached the new line here because it's a new line character. So we'll say clear flag is true. So we want to, on the next loop around, we will clear that buffer. And if self.position equals greater than 1, so self.position 1 here is just say we're going to check the buffer, we've packed a byte into it. We're going to say actually if it's greater than 1, basically we're greater than just the new line, we're actually effectively stripping out those new lines that are just maybe blank spaces between G-code line. We're not going to return those. We're just going to go. If it's greater than that, well, of course we're going to go. We're going to give a result line, and it's going to self.return. We've got to create another helper function here, utility function called return slice. Let's create that now. So return slice is just going to do take the buffer, enumerate. So it's going to have a lifetime of A. An array, a slice of U8. Up here, so return slice. No, it should hopefully, yeah. We won't need this lifetime because it should take the lifetime of the buffer. So all we're going to do here is going to say we're going to reference the inner buffer. We're going to say from 0 to self.position, return that. So yeah, so it's already adopted that lifetime there. Turn slice. There we go. Just a utility function around that syntax. So else expected line. So if I go back to meat. Oh no, it should say expected. Let's just double check what that's mismatched. So that should be a slice. Let's call it S. Let's double check this. Oh, I know. The reason why I need to actually put that as a return, don't I? It's because this branch is empty at the moment. Oops, I believe. Okay. Meatpack result. Wait for the next byte. Why is that not? Because there we go. So missing the semicolon. Return size type annotations needed. I needed a semicolon there so I can then return those, because if I don't leave a semicolon off when I'm in this match statement, I can return out of that match statement here. But this is for result E. Yeah. Return OK. Yeah, that looks okay to me. Let's see. Should be okay. It may be because I still haven't finished is ready to do on all of these. So they might return no. Not if I thought it doesn't need to infer because it's okay. Should be okay if I just let's try that. I believe it's just a case that I haven't finished the implementation down here. So we'll cross that road in a moment. So start of a new byte pack. Yeah. So here we're at the next stage here. Sorry, I'm just looking at the reference. This is saying we've got no least byte, but we've got a new byte and we know it's not a new line character, so we want to check whether it's packable. And if it's packable, then we want to either put it as a least character. If it's a full byte, then we need to declare it as a full width byte and then look for another byte that might pack with that flag. So be a pack. So we're going to match on the struct white space. So we're going to try and pack it, and if it's okay, we get that, then that's going to become our least byte. So we want to say self.least equals sum least, and we're going to say none. Oops. So we've got a new byte. It's going to become part of our. It's going to be situated in the least significant bit of the U8 when it gets packed, and we're going to do self.full width equals none. Just to highlight, that's going to catch whether full width was set previously. I think it's just to say that we know that this is not a full width byte. We're going to say OK, meatpack results, waiting for next byte. So that's that eventuality covered. In the non case, we know that the self.least is going to represent a flag, our warning to highlight that there's a full width byte coming. We're going to say set full width is true. Oh no, it's going to be actually. I'll say it's going to be this byte actually. Yeah. So we've packed it. It's not packable, so it's this byte that's going to be required to follow after whatever gets packed. So we've got this like the most significant bit available to us to pack another U4 into. We just want to give it an opportunity to fill that space up with a U4. If not, it's going to be another signal to say it's another full width byte. So we're going to have double 1111 effectively, and then 2 full width bytes. So we need to do meatpack result, waiting for next byte. So we haven't, yeah, not going to return anything there. Oh, delete that. Okay, it's still saying it's found in expected unit type. Still not sure on that. I believe that will iron itself out once we complete this section. So now we got to the stage where we are at a full width character with new lines. Oops, keyboard. So what we want to do is we want to do a match on oops, no, I'm looking at the wrong one. Yeah, so here we are going to say we know that there's a packable character going to be following this. We should have the full width, but we know that the most is going to be as this before, it's sorry, phone. So, in a second. All good. So we've got this new character that we want to, new line we want to pack, strip self dot strip white space. We can do an expect again because given a packable character. And we're going to do the packed byte is going to be the 0b111. Nope, that's in our least. So we need the most followed by the least here. Dot pack. Oops. What have we done here next? We got two, so I'll just look at it. Yeah, so yeah, that's absolutely fine. Yeah, because so I've got a constant that represents 0b111, but it's as for full width. Use me for my reference. So those are the 2 bits that we want to then pack. Why is that not? Oh, because we need to import packed. Oh, we do. You import packed total. Oh, that's an O. Wait then. There we go. That pack. Oh, so I just have to get this quickly. Okay, we should be back on it then. So dot pack expect. So yeah, given 2 packables. So yeah, we got a pack byte, and now we want to again push this to our inner. Pack byte, and we would need also self.push self.full-width.unwrap. Well, we can even do expect here. We should have a full width stored. So because we've identified that we had a full width, we should have stored it somewhere, and we'll get to a point in the match chain here where we go, we've identified a full width byte, we need to store it. We've actually done it up here, haven't we, before here? That's it, a full width byte. We've matched that. Expect still trying to figure out. Oh, I think it is because this now is fine up here. So I think the logic chain, as I build out the logic, it's going to match up all the returns because we still haven't completed the full chain. So yeah, we push that. So we expect the full width byte. So we push that. So it's going to actually be behind the new line character in the packed buffer. So we do this, and then we are then going to self.least. So now we can set these, return these to none because we've used them, and the full width to none. And OK, meatpack results, waiting for the next byte. Okay, so that's that one. We are always returning lots of. Let's just return an error just to see. Let's just return OK next byte everywhere to see if we can clean up this annotations. There we go. Right, what have we got here? Mismatch types. There we go. So yes, I didn't need that semicolon before. Sorry about that. That's it. It's just I just need to default some OKs here as we build it out. Oh, whoops! This is not okay. This is sum, of course, because it's returning an option. Right, now we've got all these right. So what we got? Let's do right. I think it's unnecessary. I thought it was. But that's because all these error messages, so we can return that. So we know that that's 2 packables. U8. Yeah, we need to put a question mark there just in case we push and the buffer is full. We need to do the same here. We build up the buffer, cleaned all that up, and yep, we are now onto the processing the next bits here. These are all used. Oh, because Impact's never used yet because we haven't published. Let's clean up all those by saying in our library pub components, pub use components. Packer. So now when people import our library, say Meatpack at the top level, this will be represented at that. So it's kind of pulling it through the module list, putting it at the top there, so they don't have to dive down to Meatpack, components, Packer, then Packer. It could be just Meatpack, colon Packer. They can import it from there. Right, so that's cleaned up all those unused elements because we're actually exposing it as an API for our library. Now we can do our next stage, which is we have a full width byte and we're not dealing with a new line, we're dealing with some other byte. So we want to then do a match b.pack self dot strip white space, and then we've got to deal with sum most. We're going to call that one. It's going to be a most character. And we also got to deal with the non. So if it is a packable character, then we will say we will pack that with the full width byte. So yeah, packed byte equal the least and the most. So this is the most, and then we're going to do one for our least dot pat expect. We can just copy this expect because we've given it two packables that we know that they are, or they should be. It's okay. We haven't finished just yet. So then we want to go copy this effectively. So we want to push the packable bytes. We want to set the full width one. We want to give it the full width one. And we should expect a full width stored. We set them all to none, waiting for the next byte. So that's good. And then we get to the non-state. Well, then we're going to have we've got two full width characters, one following after the other. So what we get here is a state where we have two full width flags. We want to push that. Going to push then the full width character. We will then want to push B, because that is our other full width character. So two flags saying full width coming along. Here's the here's the full width. The two full widths characters, the U8s. Because it's a reference, we'll have to dereference that, and we will then clear the least because we've used it. We'll clear the full width because we have now used it, and we will return an OK, waiting for next byte because we haven't reached the end of the line. And we don't need this. There we go. Now we're up to, we've got a byte in the least and we've got a new line. So we've reached a new line. We're going to want to return full pack line to the user. In this one, we can copy over, we've got the least, so this is going to become, the most significant bit. There we go. It is a new line character and we know we expect it to work. And copy over this bit, and then modify that in a moment. So we've got a pack byte, we're going to give it the most, we're going to give it the least, we're going to pack it, and we're going to expect that it's two packables. So then we want to self.push the pack byte, and we're going to self.least because none anymore, we've used it up. I have done, but this should not be the case, but we can set this to none. Again, we're resetting everything, but that should never be full in the first place. We'll set the clear flag to true because we've reached an end of line. We can then say, OK, meatpack result new line, self.inner slice, return slice. Impact. Oh, yeah, just need to put a question mark there because we may have filled out the buffer before we can return it. Well, there's no space in the buffer left, should I say. Now we get to the last state, which is now we've got something something that we've packed, and we've got another byte, so we want to just check that we can pack this. So we do that same thing again, b.pack self.strip byte space. So if we got some packable byte, then we can just do let packed byte equal most least dot pack dot expect given two packables. It shouldn't fail us. So then we want to do the self.push bytes question mark self.least becomes none. Self.full width it should be empty anyway, so we'll set it to none anyway, and then we'll do OK meatpack result. Yeah, waiting for next byte. So we haven't reached a new line. There we go. Oh, yeah, we don't need the semicolon. Yeah, it's non-exhaustive, hasn't been covered yet because we're going to do the next stage, which is the none. So in case it is not, then we know it's a full width pipe character. So we are going to go pack byte is going to be the full pack full width flag, followed by the least significant packed character. We're going to pack this and expect, because we are given two packables, or provided two I can change all the syntax later, and it's different in the library itself anyway, but hopefully you get the gist. So we've expected because we've provided two packables. Again, self.push, and I can imagine actually we should have probably a much convenience function around this. Self.push the pack bytes, self.least equals none, self.full width equals none. Shouldn't be full anyway. Meatpack result OK, waiting for next byte. Oh, and there we go. So we have now created our full packer, our packer function that's in the library. I've realised it's already an hour in, so I thought it's a good time to take a break. So what we've done, I'll just give a quick rundown, is we have created this packer function. It has a position to keep a U8, a U4 least bit, the first one that we're going to pack into a U8, wait for a one that we're going to pack into it, a most bit. We've got the full width character store, so that's storing a full width character just in case we have a flag in the least and we want to try and pack another U4 into the most segment of that U8. So this is just a store for that full width until that time arises. We've got the clear flag to clear our buffer. We've got strip white space and strip comments, which are user defined, whether it's a strip white space or strip comments. We've got the comment flag. We identify when we are in a comment zone and we ignore those bytes if strip comment is true. You know, include them if it's false. We've got a position usize to say where we are on the inner, and the inner is our buffer to store all the pack bytes until we get to a new line where we then give that entire line back to the user to do something with, and that is actually a reference, a slice into the inner. We created the default state. We created a new state where the user can customize whether to strip comments or white space. And then we'll go into the pack in just a second because we'll do the utility functions first. We've got clear inner, just wipes the inner buffer clear, ready to be used again. We have push, so we push bytes to that inner, and we return slice where we return a view into that slice with those bytes. And the thing to note actually there is that we clear the inner. That's it. We'll see that in the first bit. In pack, we clear that at the first stage. So you can imagine a user looping through bytes, giving bytes over, and then they'll receive a line back. They should then use that, either copy it out, use it somewhere, and then if they loop again and add a new byte, then that kind of reference, that slice to inner, will become clean and clear. We don't want to clear it after we've given them a line, because then of course we've just cleared the packed bytes that we need, so we only do it on the next kind of round through. So we clear that buffer. If we've already consumed it or the user's already used it and the line's been given away, we strip white space. And yeah, again, I guess with the inner, we return that slice. So we go back to that. We return that slice just in case the user is confined with some space and want to be space efficient and just want to use the bytes in place rather than having to copy them or create a new version elsewhere across. Right. Anyway, so yes, clear flag, clearly inner if we've given the user a line, and we're going to process the next line. Strip white space, if it's activated, then we'll look for white space or tabs and just return OK, waiting for the next byte, so just ignore them. So that'll then automatically pack out, not be included in our packed version of the code. We have strip comments, where we will strip on the semicolon. So if we see a semicolon, we'll say we'll flag as true, ignore any bytes in between that and the next new line, and so that means that if the comment flag is on, we'll return next byte. We'll just ignore those. And then we get actually, as always, into the meat of this, where we're actually going to look whether, check whether we've got an existing U4 least bit that we need to pack with another byte that we want another packable byte. And then we deal with all these different options, whether we haven't got anything in, but we've got a new line. We haven't got anything in, but we've got a new byte. That will then enter and become our least bit of a U8 that we'll then pack in with another U4 representation to make our packed byte. So then we can either deal with a case where it is a packable character, we put it in the least. If it's not, we'll declare it as a full width character, but in the least a flag to say the next byte that you'll receive in this line will be a full width character. We then deal with a case where we do have a flag of a full width character and we've got a new line, because those can be packed together. So we'll pack those two together and then append the full width character. So really that line in a way kind of acts beyond a new line character. So it's a bit of an odd quirk there. Then we get to a case where we have a full flag, a full width character and a new byte. So we need to check whether it's packable. If it is, then it gets packed with the flag, and then we retrieve the full width bytes that we've been holding in our stores and append that on a packed byte set. And then we then set least and full width back to none because we've now consumed them into the buffer. If none, then we know that actually we've got two full width bytes following one after the other. So we're going to do a packed byte saying, hey, look, user, we've got two full width bytes coming. So there's two flags here. We put that as the packed byte and then proceed follow with two full width characters, U8 characters, set everything back to none, waiting for next byte. There's the case then we've got a least byte and a new line byte. So in that case, we just want to return that slice, but we know we can pack those two together. So we pack that as a single U8, we push it to the buffer, clear everything out. Also flag to clear the buffer once the flag has been returned, and we return that slice. We then get to a stage where we have the least and some byte that is not a new line. So we check whether we can pack it. If we can then put that as the most significant bit of the U8 and the least significant bit of the U8, pack those two U4s together to give us a pack byte, pack it, clear everything out, wait for the next byte. In the case where it's none, i.e. that byte is a full width U8 that couldn't be packed, we will then pack a flag, say, hey, with the least, with the one that we've got, the flag is indicating that the next byte is full width, pack that, and we should have, there we go, good error there, good catch. We should have here self.push, of course. Oops, not here. Self.push the byte. There we go. And of course, question mark there, return if the buffers full. So we then push the pack byte, push the byte that we've currently got as the full width byte, set everything to none, and then OK, next byte. And that's the packer done. I think that's a good place to stop. We can then look to add some tests in a moment. I think the next stage will be to add the unpacker, and then we can try and do some testing when they're all together, because the pack bytes are quite meaningless in a way. It's hard to digest and unpack. So, but if we had a packer and unpacker, we should be able to go through that process of packing and unpacking and get the same result out, or a condensed result if we're removing comments from white space. Hopefully that was useful. And yeah, look forward to seeing you in the next one. Cheers.